Another evaporation case with exploCFD. We're modeling a double-walled ammonia tank that has sprung a leak in the inner wall, and now the interstitial space between the inner and outer walls is filled with liquid ammonia up to this level where the blue lines are. And of course, with exploCFD, you can input the Antoine coefficients of ammonia. I just got them from the NIST Chem webbook, along with some other parameters like diffusivity and dynamic viscosity, and then run the simulation. The results are in fact quite interesting. You can see the cloud forming above the tank. Of course, this is a toxic cloud, so we need to look at parts per million, and this scale starts at about 10 ppm, and you can see that the toxic cloud rises. Even though it's very cold, it's still ammonia, which at minus 33 degrees Celsius is still lighter than air. And of course, it warms up over time and mixes with air and comes back down to the ground, not because of its density, but because of the flow pattern around the facility. This flow pattern is such that there are vortices that are shed off these structures, and of course with these vortices you have a portion of it that goes up and a portion that goes down, and the part that comes down brings some ammonia vapor down with it. And you can see the levels are at about 20 ppm on the ground due to just this internal release. So the next time that you want to model an evaporation, a spill of any liquid, whether it's ammonia or LNG or something else, remember that exploCFD has the capability to do this automatically for any evaporating liquid. Does your software do this? Maybe it's time you gave exploCFD a try.